All right, welcome stats to your notes video for Thursday, September 6th. Everybody, please make sure that you have out your notes packets that you got the other day. That bad boy looks like this. All right, Stat 1300, Chapter 3, the normal distribution. I'm going to hand out your homework packet on Friday and give you some sweet examples there. So have this out. Everybody, please make sure you write this at the top of your notes. So x is equal to, or your z score is equal to x minus mu over the standard deviation, which is your x is always the value you're looking at minus the mean over the standard deviation. In your notes packets, look at page 79 and 3.8. Again, pause this whenever you need to, because I'm going to make this video under 15 minutes, so it can just be one video. Pause this whenever you need to. So on 3.8, this is what it says. 2007, when I graduated high school, somebody was a senior. Illinois scored a 680 on the math part of the SAT. The distribution for the math scores were approximately normal. Mean was 515, standard deviation 114. Gerald took the ACT math, scored a 27. They were approximately normal that year. Mean 21, standard deviation 5.1. They're always kind of like that. Find the Z scores. That's what it means for both students. So who did better, like percentile wise? And that happens too, because you guys talk about all the time that you might have done better on the SAT versus the ACT percentile wise. Anyways, let's write this down. Again, pause it when you ever need to. Eleanor got an X value. She got an 680. The mean was 515. The standard deviation was 114. Gerald got a 27. The mean was 21. Standard deviation was 5.1. Who had the higher score? Again, I'm going fast. I want you to write everything down here, so pause it whenever you need to. Let's find Eleanor's Z-score. Do 680 minus 515, that's 165, divided by the standard deviation. Always round that to the nearest two decimal places. Now, that's a 1.45. Now, I gave the percentile, which you don't need, but here's how you find the percentile. Again, you go to 1.4, and then go all the way over to 5. So 1.4, it's going to be hard on this screen. 5, so what is that? Right there. So 92.65. Okay, we'll get better at reading that Z table tomorrow. So she's in basically the 92.65 percentile. So that they might call it 92 or 93, depending on how they round. Anyway, for Gerald, do 27, his score minus 21, that's 6 over 5.1. So first off, I don't even need to find percentile. Since Eleanor had a better Z-score, she did better, okay? If you have a better Z-score, you're in a better percentile. That's how it works. But we can find Gerald's percentile, all right? So we just look at 1.18. So we go on the positive side, we go to 1.1 all the way to 8. So that's how we get the, right there, 1.1 and then 8. That's how we get the 8810. So 8810, so 88.1 percentile. Again, if we want to figure out, like, you're the top what percent, again, Eleanor did overall better. So also 92.65 percentile means the top, you just subtracted for 100, she's in the top 7.35%. Gerald was in the top 11.9%. So Eleanor did better. She had the better Z-score. So I like that example. Make sure you have that one down. That was an important one for today. Let's take a look at example next. Take a look at example 3.9. We talked about this yesterday. So women aged 20 to 29 have approximately a normal, so it's coming from this, again, 3.9. Let's just read it from here. The heights of women aged 20 to 29 are approximately normal, with mean 64 inches and standard deviation 2.7. Men the same age have mean height 69.3 inches, standard deviation 2.8. What are the Z-scores for a woman that's 6 feet tall and a man that's 6 feet tall? Obviously, the Z-score for the woman's going to be better. If you're 6 feet tall as a woman, you're definitely taller percentile-wise than a man that's 6 feet tall. Okay, so let's take a look. Let's do that for both. Here it is. Now, notice how I wrote this. This stands for normal distribution, the mean, and then the standard deviation. All right, that means normal distribution with a mean of 64 and a standard deviation of 2.7. I'm going to start writing that soon. It's always written as capital N for normal, then you write your mean and then standard deviation. So for the men, they are approximately normal, capital N, with a mean of 69.3, standard deviation of 2.8. So a woman that is 6 feet tall is 72 inches. Let's find her percentile. All right, so we're going to find both. Her x value is 72. Do 72 minus 64. Divide that by 2.7. It's a z-score of 2.96. Wow. So 2.96. Let's look that up on the z-table. Go to the positive side. Go to 2.9. Move that all the way to 6. Notice how there's no difference here. When your z-score gets so big, it really doesn't move much. It's going to be 99.85. Again, look all the way up to, you got to look up to the 6. Match up 2.9 and then 0.6. So where are we at? Right there. 99, so 0.9955 means the proportion of people that are, of women that are smaller than her is 0.9955. So almost all the women are smaller than 6 foot, or 6 foot or smaller, that is. So she's in the top 0.15%. She's definitely top 1%. Wow. So a man that is 6 feet tall, okay, 72 inches. Let's find his z-score in percentile by. So x is 72, so your z-score is 72 minus 69.3. You're going to divide that by your standard deviation. So 0.96, a little less impressive. Still, positive z-score, above average height. Let's go to 0.9 all the way over to 6. So that's how we get the 83.15. Again, 0.9, and then follow that row over to the 0.6 column. That's how we get 83.15. So his percentile would be 83.1%. If you want to find what he's in the top what percent, just subtract it from 100. So he's basically in the top 17%. So there's a big difference in being 6 foot for a man versus 6 feet for a woman. That's an important example. Now, folks, here is the most important example, an extra special example. Mr. Yak is 70 inches tall without shoes. Thank you very much. What percentile is he in? Remember, the mean for a man is 69.3. Standard deviation is 8.2. So let's find my z-score. It is 0.25. So when you look up 0.25 on the positive side, thank you very much, 0.2, move over to 5, that is 5987. So 0.5987, again, guys, if you read this, that's giving you the proportion that is to the left. It always gives you the proportion that is to the left. So 59.8% of men are my height or shorter. So basically, I am in the... Oh, so I did that wrong. No problem. I'm in that percentile, so I'm in the top 100 minus, I'm in the top 40% of heights. Okay, this is an interesting question. So Muggsy Bogues was one of my favorite players as a youngster. He played in the 80s and the 90s and maybe early 2000s. He was literally 5'3", an NBA point guard, believe it or not, the shortest player in NBA history. What proportion of adult males are taller than Muggsy? Again, it could be that. I'm pretty sure it's 2 G's. So 63 inches, that's 5'3". So his z-score is going to be negative. He's going to be below average height. Okay, so what you do is you look up on the negative side, go to negative 2.25, negative 2.25. I believe that is the, is that the 0.122? Anyway, I wrote it down. So basically 1.22% are his height and shorter. So if I want to know taller, I want to go to the right. So anytime I want to go to the right, I need to find the complement. So 98.78% of men are taller than Muggsy, or a proportion. Again, a proportion is between 0 and 1. That proportion to be 0.9878. All right, folks, now we're going to go back to your packet. Again, pause this, definitely. Now go back to your notes packet, page 83. We're going to do some of these questions together. All right. And actually, very well prepared. We're going to do 3.10. 0, so 3.10 together. I want to use table A, which is your z table. It's called different. It's not called table A here because you don't have this book. To find the proportion of observations from a standard normal distribution that satisfies each of the following statements. In each case, you don't have to sketch except for D. We are going to sketch one for D. Okay, so if I want a z-score that is less than 2.85, again, that's exactly what the z-table tells me. It tells me the proportion that is less than that z-score. So I simply look up 2.8, go over to 0.5, which I wrote down here. That proportion is 9978. Because I want it to be less than, I simply keep that. All right, so 0.9978. So 99.78%. We're going to have a z-score that's less than that. Now for the greater than portion, obviously if almost everything is less than that, then a very small percentage is going to be greater than that. Anytime you want greater than that or something to the right, you always subtract from that proportion that z-score gives you. Again, we're going to practice this more tomorrow, so no big deal. All right, so that is 0022. I think part C asks for another greater than. So let's look up. Now, let's think about this, folks. I want to know what proportion is greater than a below average value. Well, if it's below average, then most people are going to be above that, right? So look up negative 0.166. I believe that is the 0485. So 0485 or 4.85% does that or less. So the percent that does better is the complement, 95.15%, or 0.9515 do better than that. Now, this is a very good question on D. We're going to have this a lot, like what proportion falls between two heights or two scores. So what I got to do is I got to look in my Z table. Here I got to look up negative 1.66, 1.66, somewhere in there. It's that one. Oh, we already found it. It's 0485. Then I gotta look up 2.85, which again, if you already did it, you don't need to, but you go to 2.85. You guys know how to use this. 9978. Guys, if I want to know what proportions in between, then I simply take like that area and I subtract where that is. Okay, so I do 9978 minus 0485. Again, we'll do this tomorrow. And I get 0.9493 of my area of the normal curve lies between those two values. All right, what we're going to do is we're going to look at 340 real quick, and then I'm going to make a second video for the next part. Okay, let's look at 340. This is going to be the last part of this first video. Unfortunately, it's going to have to be 2 videos, but no big deal. You can just have all these notes. I'll answer all your questions on Friday. It'll be a lot easier, I promise. So folks, you can actually on the SAT, you can score higher than that. Again, this came from 2007. They actually changed the test between them to make it out of 2400, but now it's back to 1600. So scores that are above 1600 are just reported as 1600. So in 2007, the distribution of SAT scores was close to normal with a mean of 1021 and a standard deviation of 211. What proportion of students actually scored 1600? Well, 1600 is your x value. All right, you're going to subtract the mean, divide by the standard deviation. All right, so that's going to be 2.74. Look up 2.74. There's 2.7. Go to the 4. I believe it is 9969. So 99.69% did that or worse. So who got a 1600 or better? Just subtract it from 1. 0031, if you move the decimal over twice, you get 0.31%. So if you get a perfect on the SAT, you're in the top 0.3%. Wow. Anyway, folks, this is video 1 of your notes. For the second part of the video, we're going to go back to page 87 and then just continue from there. All right, so switch over to the next video now.